Okay, Extension 1 students, we're going to look at the Bernoulli distribution. This is my second attempt at the video after the audio did not record due to a software problem. Okay, so we're looking at the Bernoulli distribution. A Bernoulli random variable is a discrete random variable used when there are just two outcomes, success and failure. So for example, if we're looking at tossing a coin, that involves success or failure. If you define, say, heads as the success, there's only two possibilities, heads or not heads. If you're shooting basketball free throws, you either hit or miss, so success or failure. So those are examples of mathematics involving the Bernoulli random variable. Okay, now a Bernoulli random variable is capital X equals 0, 1, where 0 is failure and 1 is success. Now, let's have a look at the first example. Which of the following are Bernoulli random variables? Okay, so for the first one part here, let's start off by saying, well, X, well, I'm just going to write down X can be 0 or 1, where I'm defining success is tails and failure is heads. So 1 is success, so that's going to be tails in this case. So the answer is, let me just type this up because it's a little bit neater. Text. Let's have a look. Here we go. All right. So this can be described by a Bernoulli, it's a bit wider. By Bernoulli random variable. Yeah, only two outcomes. Okay, go back to our pen. Okay, what about the numbers rolling on a die? Okay, so this would be quite straightforward to write down. There's only 6 possibilities in there. So 1, 2, 3, 4, 5, 6. All right, and obviously there's more than 2 outcomes, so we would say this cannot be described. So I might just copy this. Oops. Yeah, there we go. Copy that, and let's put that down here. I'll change to cannot be described because there are more than 2 outcomes. Okay, now let's do the next one, the hitting the bullseye. Okay, well, we can describe this as X equals, I'm just going to go 0 and 1 again. 0 and 1. Now, 1 is always success, so that's hitting the bullseye. And missing the bullseye. Okay, so Now, in terms of our answer, it'll be the same as this one, won't it? So if I go to text, here we go. Here, paste. Okay. There we go. Right, this can be described by Bernoulli random variable because there are only two outcomes. That's correct. Okay. Now, what about the number of goals scored in a hockey match? Well, what could X be? Well, you might not score any goals. You might score 1 goal, 2 goals, 3 goals, 4 goals. Who knows how many goals? Okay. So, in terms of our answer, I'm going to come back to here. And here we go. Okay. Now, next one, choosing red ball. Well, we've got red, white, and blue balls. Choosing red ball is our success criteria. So we can describe this 0 and 1, where obviously 1 is choosing red and 0 is not choosing red. Right? Now you could write this as not red. That's the notation. Obviously you could write that as red. Okay, so what's our answer for that one? Well, same as before. See, that is. Okay. Now, okay, there'll be our answer. So this can be described by Bernoulli random variable because there are only two outcomes, red and not red. Okay. Alrighty, now part 2. Construct a discrete probability distribution table and bar graph for rolling a 6 on a die. Okay, so let's have a look at how we're going to do that. Okay, so for the solution. Okay, let's look at part A. All right. Now, probability of getting a 6 is obviously 1 over 6. Yep. And the probability of not getting a 6 is 5 over 6. So, how does our probability distribution table look like here? Okay, so we're going to have x up the top and the probability of x equals x down the bottom. Okay, so remember we're looking at success and failure. So failure is 0 and 1 is success. So if we're looking at failure is not getting a 6, which is this one over here. So that's 5 over 6. And success is getting a 6, so that's 1 over 6. Okay, So that's the probability distribution table. And we're going to also define that 0 is equal to failure and 1 is equal to success. For our probability distribution. Okay, now what about the bar graph? Okay, it looks like this. Okay, so here we go. All right, so what have we got here? We've got the probabilities on the vertical axis. We've got the success or failure values on the horizontal axis. Okay, so you've got 0, obviously the probability of failure is 5/6, probability of success is 1/6. There you go. All right, now part B. Part B says, okay, is this a uniform probability distribution? And the answer is no. And the reason is this is not uniform probability distribution. Uniform means the same. So we're going to go since the probabilities are not equal. Since the probabilities are not equal. Okay. Now, alternatively, you could have also said that the probability of success is not equal to probability of failure. So you could have also gone probability of success. So if you wanted to write something briefer, not equal to probability of failure. Therefore, not a uniform probability distribution. Okay. All right, let's have a look at the next part. Now, a Bernoulli distribution is a general probability distribution for a Bernoulli random variable using P as the probability of success, and the probability of failure is defined as Q, which is 1 minus P. Okay, so let's have a look. So for our Bernoulli distribution, we can now write that in terms of P. So probability of x equals x is P for x equals 1, where 1 is your success, and 1 minus P for x equals 0, where 0 is your failure. Now we call P a parameter, and in stats, a parameter is a constant that describes a feature of a distribution. Okay, so let's have a look at part A. It says write a Bernoulli probability distribution for each situation. Passing a test where the probability of a pass is 56%. Okay, so our success criteria is, or success value is 1. So I'm going to say 56%. And the probability of failure is 44%. Okay, you should also define where 1 is equal to pass or success. And over here, where 0 is equal to failure. Okay, now to write this as your Bernoulli distribution, let's do that. So we're going to write down probability, capital X equals X, equals, parentheses, 56% is our success, and that's for X equals 1, and 44% for X equals 0. Okay, let's look at the next one. We have flipping heads on a coin. So heads is our success criteria here. So I'm going to say probability of 1 equals a half, where 1 equals heads, and probability of 0 is equal to a half, where 0 is not heads. Or you might just say tails. Okay, so now we can write down the probability distribution for that, Bernoulli probability distribution that is. So starting off with the same way as previous example. Whoops. Okay, so probability of X equals X equals, and we're going to have, first one was a half, so success first, where 1 is equal to heads. Oops, that should be X equals 1, sorry. That should be X. X equals 1, and the failure part is getting tails, and that's obviously X equals 0. Okay, let's do these, fix up these brackets here. There we go. All right. Part 3. Part 3, we've got the probability, selecting a red ball, so that's our success criteria. So I'm just going to go probability of red, that's 7 out of 15. Where 1 equals red. And probability of 0 is 8 on 15, where 0 is equal to not red. So not red. Or you might just say blue. Okay, so now we can look at writing Bernoulli probability distribution. Okay, so let's have a look. So probability of X equals X is equal to, okay, success first, 7 over 15, where X equals 1, and then 8 out of 15, where X equals 0. Now, last bit, which of the distributions in part A are uniform? So you're just looking for where the probabilities are equal. So obviously part 2. Okay, so I would write down this one here. A part 2. Since the probabilities are equal. That's what you've got to say. Okay. Alrighty. Now, let's look at mean. Now, the mean or expected value of the Bernoulli distribution is E of x equals P. E of x equals P. So let's have a look at a proof of that. Okay, so starting off with the Bernoulli distribution definition, which is here. There we go. And definition for variance, so not variance, is expected value. The definition of expected value is sigma x p of x. Okay. Now, there are two possible values for x, 0 and 1. So let's start off with the first one. So you're going to have 0, I'm going to do 0 first, times p of 0, and sigma means we're adding. Next x value we're looking at is 1 times by p of 1. Okay, now that's obviously 0 times p of 0 would be 1 minus p plus 1 times p of 1. P of 1 is just p, isn't it? Okay, so p of 1, you can see that there. Just there. All right, so what's that give us? Obviously 0 there, plus p, which is equal to p. All right, so let's have a look at our first examples here. So, find the mean for each Bernoulli distribution. Rightio, so let's look at part A. Now, starting off, we know that probability x equals 1 is equal to 4/11. Okay, so therefore, we can say that p is equal to 4/11. So therefore, the mean or the expected value is equal to 4/11. Okay. Next one, part B. Now, we've got P of 1 is 9/10. Therefore, P is equal to 9/10. So the mean or the expected value is equal to 9/10. And you could go just straight to that last line there. Whoops. Here we go. All right. Now, let's go on to variance. Now, the variance of a Bernoulli distribution is defined as var x equals p1 minus p. So we looked at that before in the 2-unit course. Here's a proof. Now, don't forget, there's our Bernoulli distribution. Here's our definition for variance. So we're just going to use that formula. So we'll start off with looking at the case when x is 0. So you're going to get 0 minus. Now, e of x here, it's your expected value. We said that was equal to p. So you can have 0 minus p all squared times p of 0 plus, now the next value we looked at was 1 for x minus and p all squared times p of 1. Okay, so it's going to give us p squared times, now p0 is 1 minus p. Plus, well, that's 1 minus 2p plus p squared times p1. P1 is p. Okay. What does that equal? So you're going to get p squared minus p cubed plus, well, let me just fix up that 3 there. P cubed plus p, so I'm just expanding the brackets, 2p squared plus p cubed equals. Okay. So let's do some simplifying. All right, so we've got minus p cubed plus p cubed, they go. And then we've got p. Where did my little pen go? All right, there it is. Okay, so we've got p, and then p squared minus 2p squared is just minus p squared. And that's equal to p outside of 1 minus p. Done. Okay, so let's have a look at an example involving that result. So it says find the variance for each Bernoulli distribution. Okay, so let's have a look. We've got, for the first one, okay, so 0.6, so that's your success. So p is 0.6. Okay, so now that's a capital P for probability, and that's lowercase p there, so we can use that for our variance formula. Now we know that var, or variance, is p 1 minus p, which is just 0.6 multiplied by 0.4, which is just 0.24. Okay, what about the second example? We have, okay, starting off with P1 is equal to 3/5. Right, that means P is equal to 3/5. We write down our variance formula. Rx equals P outside of 1 minus P, which equals 3/5 multiplied by 2/5, which is 6 on 25. Okay. All right. Now, just one thing to note. We know that var x is P outside of 1 minus P, but we could also write this as PQ, where Q is just 1 minus P. Okay, so that's another way we could represent var x a little bit neater. Okay, so just this last bit there. Okay, all right, so now you're ready to start the designated exercise, which is 15.01, and hopefully my audio was recorded.